Okay, another problem of a surface charge in the shape of spherical surface. It is a charge density of 8 coulometer per meter square, but this time this surface has a particle, small particle, which has the mass of 2 kilograms, and it has the charge of 2 nanocoulomb. It is just located on somewhere on the surface. Let's put it over here. Okay, it's a charge Q. And the question is that since both this spherical surface and this point particle has charges of the same sign, obviously when you just release the particle right on the surface, the particle will experience a force which is radially outward, okay, from the surface of the sphere. And because it's under a force, imagine that there is no gravity, what is going to be initial acceleration right on the surface, okay, because it is going to be just repelled at a strong force repelled by the surface because it's charged. So we know that how to calculate the electric field right on the surface, right? Well, on the surface, the charge, which is we have a non-zero charge. Then if we have a charge in an electric field, then the charge will experience a force of this quantity, the charge magnitude multiplied by the electric field at the point, at the location of the charge. We can always calculate the electric field from our previous problem solving sessions, that if you, as long as you know the surface charge density right at that point, you can find the electric field because it's a surface. So there is an electric field over here. And so since these both charges are the same sign, plus charges, the force is going to be again in the same direction as that of electric field. So it will experience acceleration in this direction also. All the force, charge, and electric field are going to be in the same direction. So, but this force is going to be just mass times acceleration. So acceleration is going to be just Q electric field divided by mass. Okay. So the charge is 2 nanocoulomb, 2 times 10 to minus 9. The electric field is just sigma divided by epsilon 0, right? Sigma, the charge, surface charge density 8 coulomb per meter square, and divided by 8.85 times 10 to minus 12. And the mass is 2 kilograms. So all you need to do is to calculate this quantity. It is going to be like 9 times 10 to 2, if I'm not wrong, which is 900 meter per second square, since this acceleration. So it's a huge acceleration, right? In only 1 second, this particle will get a speed of 900 meter per second. But of course, only this acceleration is only at the surface. As the charge moves away from the surface, since the electric field is going to decrease, the force is going to decrease and the acceleration will decrease. The acceleration will not be constant during the motion of the charge. It's going to be decreasing, but it's going to be always in the same direction, in the outward, radially outward direction.